Hello everybody and welcome to my video on sporulation and Bacillus. My name is Erica Gallant and this is for Cellular Biology 4770 at Shawnee State University. When we think of cell cycles within bacteria, Bacillus specifically, we're going to mostly be thinking about this. This is the vegetative growth cycle, and this is when the cell is just growing and dividing as normal. We can see the end product is 2 more bacterial cells that are also going to go on and continue the cycle. However, when we switch to sporulation, we can see that our product is an endospore, and this cycle is not going to immediately continue. The purpose of the endospore is to stop the cycle for a period of time before returning to this phase to continue. So let's break it down a little bit more and make it make a little bit more sense. So here we can see we have a cell that has just come out of the vegetative cycle, and we see the chromosome starting to condense itself and line up. Then we're going to see that chromosome divide itself. So now we're going to have one copy of it on each side of the cell, and this septum is going to start to form here in the middle. That septum is eventually going to pinch in, and we're going to see a forespore produced and a mother cell produced. The forespore is often smaller, as we can see here. Next, we're going to see that mother cell engulf the forespore. This is going to leave us with a double membrane surrounding the forespore. Here we can see that double membrane a little bit better. And if we notice on this side of the cell, the mother spore's chromosome is starting to break down. So as that chromosome is breaking down on the mother cell side, we're going to see this cortex layer made of peptidoglycan start to form in between the forespore membrane and the mother cell membrane. This cortex layer is going to be super strong and is going to be what helps contribute to the longevity of the spore. As we can see, the mother cell has completely dissolved its chromosome, and now we see dipylconic acid and calcium coming in to help form a spore coat on the outside of that mother cell membrane layer. So basically, the rest of the mother cell is going to dissolve itself and disappear, and we're going to be left with just our spore. Now, why do we want to switch over to making endospores? Well, it's an adaptive response. The endospores created are extremely resistant to chemicals, heat, radioactivity, freezing, and drying. This is because they are dehydrated and they're metabolically inactive. This is going to give them extremely long lifespans lasting up to 250 million years. They're very resistant to ordinary cleaning methods and can only be destroyed at pressurized steam that is at 120 degrees Celsius for 20 to 30 minutes. They will restart the cell cycle and go back into creating more and more bacterial cells when conditions are more favorable, as we often enter this cycle because of unfavorable conditions, such as not enough nutrients. I would like to thank you all for watching. If you have any questions, leave them below. These are my sources that I used, and thank you for watching.